In this video, we are going to wire a real database into a FastAPI application. You will learn how to create, read, update and delete rows, how the session dependency keeps your database connections clean, and how to map database rows into the exact response shape your API promises. The moment you add a database to a web app, a wave of boilerplate follows. Every endpoint needs to open a session, run its query, commit on success, roll back on error, and then close the session no matter what. Skip any one of those steps, and you either leak connections or leave rows in a broken state. On top of that, the raw database object often contains columns you never want to expose, like hashed passwords or internal IDs, so you end up writing yet more code to strip them out before returning a response. Think of a database session the same way you think of a shopping basket. You grab one at the entrance, put things in, and when you reach the till you pay, that is committing the transaction. If something goes wrong and you walk out without paying, the items go back on the shelves. That is a rollback. Either way, the basket gets handed back when you leave the store. FastAPI's session dependency is the person at the door. They hand you a basket, wait for you to finish, and take it back every single time without you having to remember. SQLModel is a library by the FastAPI author that merges a Pydantic model and a SQL alchemy table into one class, so you only define your fields once. A session is the object that tracks every change you make before they hit the disk. Think of it as a staging area. The function called getSession is a FastAPI dependency. It is a generator that yields exactly one session per request and closes it afterwards. The write pattern is always the same 3 steps: add, commit, refresh, and response model on the root decorator ensures only the fields you intend are returned to the caller. Starting at the top, we create a SQLite engine from a connection URL and create db calls SQLModel to emit the create table statement on startup. Next, we have 3 model classes. ItemBase holds the shared fields, name and price. Item extends it with table equals true, which tells SQLModel to map it to a real database table and adds an auto-incrementing ed as the primary key. Item read is a plain Pydantic model, no table, used only for responses. It exposes the ID but hides anything you might add later that callers should not see. The getSession function is a generator dependency. It opens a session using a with block, yields it to the root function, then closes it automatically when the request finishes, even if an exception is raised. In createItem, we call model validate to copy the incoming data into an item instance that the session can track. Then add stages the row, commit flushes it to disk, and refresh rereads the row from the database so that the auto-generated add field is populated on the object. Finally, returning db item works because response model equals item read filters the output to only the fields defined on item read. In read item, we use session.get, which is a primary key lookup, and raise a 404 if nothing is found. When a request arrives, FastAPI resolves all dependencies before calling your root function. GetSession is a generator dependency, so FastAPI runs it up to the yield, grabs the session object and passes it in. Your root does its work, writing or reading rows, and returns a value. FastAPI then resumes the generator past the yield, which exits the with block and closes the session cleanly. The consequence is that you never manually open or close a connection in your root code. The trade-off is that each request gets its own session, so objects from one request cannot be passed into another without reattaching them. Reach for this pattern anytime your data must survive beyond a single request. User records, orders, inventory, and when several routes share the same table. The session dependency earns its keep because it guarantees cleanup even when a route raises an exception. Use response model anytime the table has columns, like passwords or internal flags, that callers must not see. Skip this pattern if your data is purely in memory, if your endpoint only reads static configuration, or if you are still in the earliest prototype stage where a plain Python list is a faster starting point. Let us lock in the 4 things that matter. First, every write follows the same rhythm. Add the object to the session, commit to persist it, then refresh to pull back any database-generated values like the primary key. Second, your getSession dependency handles the full lifecycle, open, yield, close, so your root function never touches connection management. Third, always define a dedicated response model so database internals stay server-side. And fourth, use session.get for primary key lookups and session.exec with a select statement for everything more complex.